we're going to look at an algorithm that's used to develop the greatest common divisor. This algorithm was actually developed by Euclid in 400 BC, and to follow through the example, what we're going to do is we're going to assign b equal to 667, a equal to 261, and then what the algorithm does is it asks whether or not a is not equal to 0 and b is not equal to 0. So while those both are not equal to 0, we run the rest of the code, which is this if statement here. And it's going to ask if a is greater than b, then assign a equal to a minus b. If it's not, so else, we're going to assign b equal to b minus a. So to start out, what we're going to do is we're going to ask if a or b is 0, and neither of them are. We're then going to ask, is a greater than b? And it is not. And so we're going to take b minus a and set it to b. And so we take 667 minus 261, assign that to b, and we get 406. We then rerun it because while those two are not set to 0, we're going to continue to run this part in the middle. Now b is greater than a, and so we're going to go down here to else. We're going to take 406 minus 261 and assign that to b, which gives us 145. Again, a is not 0 and b is not 0, so we're going to continue here. But in this situation, a is greater than b, so we're going to take a, subtract b, and have it assigned to a, giving us 116. Now we're going to run it again. Again, neither of them are 0. We're going to have 145 minus 116 under the else, giving us 29. We now ask again, are either of those 0? They are not. And if a is greater than b, what we're going to do is we're going to take a and minus b. And so what we have is 116 minus 29, assign it to a, which is 87. Running again, we're going to take 87 and subtract 29. Running again, a is again greater than b, and we're going to take 58 and minus 29, which is good. And now what we're going to do is run the program. Neither of them are 0. If a is greater than b, it is not. And so we're going to go to the else statement here, which is b minus a, so 29 minus 29 equaling b to 0. And then what will happen is the next time we run, we'll actually find out that neither of those are 0, so our program terminates or ends. And so to do this, what we're going to do is we found that 29 is the value that we believe is the most common denominator, or the largest. And so to do that, we're going to take both numbers and check and divide them out, and hopefully we get a whole number. So to do this, we get 667 divided by 29 is 23, and 261 divided by 29 is 9. So it looks like we're in good shape. And now we're going to go and code that within MATLAB. Now let's look and see how we can develop this greatest common divisor algorithm within MATLAB as code. For good practice, we'll start by adding a header at top, which just gives us the author's name and the purpose for the code. Then we're going to have two inputs, one for A and one for B, to allow the user of the code to be able to type in different values and allows it to be more flexible. What you'll see as you get along further within MATLAB, you'll actually turn this more into a function and not use these inputs. But for right now, they serve our purpose very well. Then we start with our while loop here. And it's going to say while A does not equal 0, and this double ampersand sign here, if you've not known what that symbol's name is, means and B does not equal 0. So let me say that quickly. While A doesn't equal 0 and B doesn't equal 0, do this until it doesn't, until it does. And when we have that, we're going to run this if statement, which says if A is greater than B, then assign A equal to A minus B, else take B and assign it to B minus A. And so we run that through just like we did earlier. Once we have A or B equaling 0, it's allowed to exit this loop, this while loop. And what we're going to do is we're going to take GCD, or my greatest common divisor, and set it equal to A plus B. Since one of those two are 0, we're going to get what the value is of our greatest common divisor. Now, to get that out, I will see it up here in the workspace, but I will see something kind of fancy, which is this fprintf, which is we're going to display this string right here. I then tell it to go look for a decimal value, which is relational to this variable, and push enter. I'll show you what that is in a second. When I click run, it's going to ask me what is my value for A. I'm going to set it to 45. What is my value for B? I'm going to set it to 15. Very obviously, since 15 goes into 45, I should find out that my greatest common divisor is 15. And what this fprint did was it came back with the greatest common divisor is, we're looking for a decimal value of this variable, the next variable lined up, right? So I went and found 15 there. And then this little dash n, all it does is push enter. And so after the 15, my little arrows to add code go to the next line. So to check this real quick with our last one, we're in the same numbers. So I'm going to select run. In our last example, A was 261 and B was 667, and we should get 29. We get the greatest common divisor is 29. That's wonderful. We also see it up here in the workspace. Give that a try, and hopefully it works out for you very well. If not, come back to the video and see what's different between your code and what you see in front of you here.